Hi there, Turgeon here, bringing you physics from afar. Momentum practice test, you have to listen. Honestly, a lot of kids still aren't listening to these videos. My teaching's only good if you hear the words. Let's go right to number 30. We're not going to necessarily just say egg broke or egg didn't break. Now this is really important. I want you to write a little note down here. Put a little star. I want you to write a note to yourself right there. For all of physics, never just take a guess. You want to have the habit, the impulse, no pun intended, to compute. You want to just habitually compute things. Look for the equation, calculate something to be sure, to get an exact value. Now I went through and I calculated and I got 70, 14, and 7. What was it that I was actually calculating? We want to use this equation that you're going to use on the quiz tomorrow. Ft equals m triangle v. Yeah, you should know that. You should know that. What I mean by should know that, I don't mean that it should have come across your brain and you're doing something wrong if it didn't come across your brain. What I mean is that's something you're responsible to know as you study. Notice that in physics, it's always like the same equations over and over again. In every unit, there's 2 or 3, maybe 4 concepts that keep reappearing over and over again. And this one keeps reappearing. There's impulse, there's momentum. Impulse is the change in momentum. I calculated the force. If you plug in the values, for example, I don't know the force, so I can write F times 0.01, and then I'm going to set that equal to m triangle v. The mass 0.05. This is not going well. I didn't plan this out. Let me write it down here. F 0.01 is equal to the mass, and the 14 is the change in velocity because it immediately went from 14 down to 0. That was the velocity just before impact. You multiply these two, then you divide by this. Again, this is where in a video you got to listen, and I will, if you slow this down, you just listen, you can do this, you can do this, you can do this. When you come to me for extra help, this is what I'm going to say. Multiply these two. You get 0.7 divided by 0.01. You get 70. That's the force. That's the force. Label this force. And the result is 70 is more than the breaking point of the egg, which they tell us is 25 newtons. Okay, so the egg breaks. Do the same thing for 0.05 seconds. This is just like we tried to do in the egg drop project. That was the point of the egg drop project. If you didn't get a great grade on the egg drop project, you can go back and talk to me, and when we could look at this again, but you were trying to increase the time. Egg doesn't break here because it's less than 25 newtons. Go back, rewind, and listen to what I said about what is the thing he wants us to write with the star there. And if you didn't write something there, you're not going to get full credit. You got to listen. Okay, so then blah, 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 words, words, words. I called this number 31. Very, very long and confusing, hard to see. I highlighted cart X. This is cart X in the pink. Hope that shows up nicely on video. Cart X is the pink. Might look reddish on your video. So the cart X, it's like, okay, it's starting out, then something happens and it levels out with cart Y. Cart Y started here on the horizontal axis, blah, 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 all this stuff, sticky tape. Note the masses. Look, it tells you the masses. You need the mass to compute momentum. That's on the quiz tomorrow. Okay, so when you look at the question for number 31, it tells you all this other stuff, and I'm going to ask you this on the quiz tomorrow as well. I can see this is a different trial where they're not sticky tape, they're magnets, so they bounce again, same masses. Then it says, what's the momentum of cart X before the collision in trial 1? So this is confusing, I admit it. I mean, yeah, these questions, they're throwing you around. You got to look for information. Just take a deep breath, read it. Okay, trial 1, cart X. Okay, let me look for trial 1. Cart X. Oh, that's not it. That's trial 2. Okay, trial 1, cart X. And then it says before. Okay, before the collision. So, oh yeah, that's right here because this is where the collision happens. So that's 0.6 meters per second momentum. In physics, we always think, what is the equation? Don't be that kid who just looks at this and goes, oh, I'm going to grab a number so I can get on with my day. No, don't do that. Don't do that. In physics, you need an equation. So P equals mv. Momentum is equal to the mass. There it is, 0.5 kilograms times the velocity I just said was 0.6. And I'm going to tell you the answer, but you got to listen. It's the one that's 0.5 times 0.6, which is 0.3. It's in there. I'm not going to circle it for you. You got to listen. Okay. This one's really weird. Which of the following graphs represents the data from trial 2? Okay. So with trial 2, I'm going to tell you, you don't even have to calculate. In this case, I know, oh, you're contradicting yourself, Durgeon. No, in this case, it doesn't ask me for a number. It says which matches. So if it doesn't ask you for a number necessarily, you don't necessarily have to calculate, although you could. Now watch this. It says trial 2. So I'm looking at trial 2, and I'm going to look at cart X. Cart X is positive, then there's a collision, then it's negative. Cart Y is 0, and then it becomes positive. Oh, so I'm going to look at the slopes. I'm looking for one where cart X goes positive, then it's negative. Cart Y goes 0, then it's positive. That's it right there. I'm not going to circle it for you. You got to listen, but it's C. Because, and I want you to make a little note. Make a little note here. Because if you look at the original graph, which was a velocity graph, you can tell that the velocity was positive for cart X, then it was negative. And the velocity for cart Y was 0, then it was positive. So just rewind. I mean, I'm not going to say that over and over again. Rewind what I just said, and then you'll get that. Okay. Now this one asks about energy. What the heck? I know. Seriously, I've had the same reaction to this question. I've never seen a question like this before, I didn't want to tell you all this when I assigned this to you yesterday, but I knew this was going to be hard, and that's why we spent class time, and that's why I was hoping people would talk to each other in groups. It's okay. I'm helping you with this. I want you to make corrections. I want you to preferably do this in a different color. Let me tell you what I'm thinking here. If you look at each one of these in turn, just make a little note under each of these, okay? Gravitational potential energy is caused by height. Kinetic energy is caused by motion or velocity. Magnetic potential energy is weird and we've never heard of it before. So you're like, whoa. Put a question mark there. I'll explain that in a second. Then they say when the carts are closest together, what's the energy? The gravitational potential has to stay the same because they don't change height. The kinetic energy goes to 0 because it even tells you that the carts come to a brief stop. So there's no kinetic energy. The magnetic potential energy has to be 1. And I want you to make a little note here. Has to be 1 because we have to have the same total energy. We can't lose any energy. So the total energy between all of these, if you add 0.25 plus 0.75 plus 0.25 is 1.25. Okay, well there's my 0.25. This has to equal 1 joule because this kinetic energy had to go somewhere. So what happens is as they get closer together, like a spring being compressed, it builds up magnetic potential energy, which then what happens? Then they fling away from each other. And it looks like they just bounced. That's what happens every time you bounce basketball. If I'm talking too fast, just rewind. I mean, you know, I'm trying to make the video as quick as I can. So then this one asked me about, this one asked me some questions that you can't really see the answer choices. And in class I said, all right, just try to fill in this like it was a fill in the blank. And I'm giving you some choices now. Lost or gained or conserved. In trial 1, momentum, the answer is conserved. It never loses momentum. Okay. Momentum can't be lost in a collision. The total momentum before is the total momentum after, so you can't lose any. The kinetic energy in trial 1, look what I boxed in. Kinetic energy after. Kinetic energy before. Notice you have 0.09, then you have 0.03. So kinetic energy, was it lost or gained or conserved? You figure that out. But look, it went from 0.09 to 0.03. So kinetic energy, was it lost or gained or conserved? Fill that in. Trial 2, 0.09, 0.09. Oh, so momentum was conserved again because momentum is always conserved. Kinetic energy was I don't know, you tell me, was it lost or gained or conserved if it went from 0.09 to 0.09? Finally, we have some of the cards, kinetic energy was transformed. Select 2 different types. Well, we learned that when things collide, they lose energy and some heat is generated. Heat is a form of thermal. And also you can hear it. So you can hear it and there's heat generated. Okay, remember, to get full credit here, make sure you fill in the blanks, all these blanks that I created. Follow along with me. If I'm going too fast, just take a deep breath and just rewind. Okay, fill in these blanks, pause it. You know, I recommend printing it if you can. If not, you could just number. You could fill in the blanks. This has been Physics from Afar.